Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Incoming Dark Star. Now, I recently took part in a live stream in which Terrell Croft presented his evidence regarding the incoming star, which he calls Black Star, and its effect on our planet. Now, the fact that he is able to correctly predict earthquakes and use earthquake data to track the movement of these objects suggests that the object is indeed coming in toward the sun. Also, the fact that the object seems to be following a normal trajectory and gravitationally and magnetically influencing the Earth suggests that this is not a dead star or a stellar core. And you may find some details about these objects and what they look like in my article 116 entitled Planet X Objects, Unbelievable Evidence and Size. And this is the chart that Terrell Croft has come up with regarding several earthquakes that correlate with the position of this object. And future events are for May 15th this year and another one for May 20th next year, where he predicts that a large earthquake is supposed to occur due to the Earth's interaction with this object. Now, stellar cores are dead stars which seem to have exhausted the ability to generate gravitational energy. This gravitational energy is photon energy, which is within an object's particles, and it manifests as heat or kinetic energy and therefore as motion of the particles. And you may look at article 191 entitled The Photon Universe. It is all made out of light for more details on that. Now, this causes the stellar cores to interact very weakly through the gravitational interaction with other objects in the solar system because they have such low gravitational energy. Now, they seem to also no longer have a negative outer layer and thus do not draw a current from the solar capacitor and therefore do not develop comet tails as they come in toward the sun. And you may look at article 203 and article 184 where that's described in detail. Now, what we see here is one of these objects, a stellar core, in the sun's corona. They have invaded the solar system. They come into the sun's corona and they interact with the sun. They draw material from the sun and through that draw energy from the sun because the sun's particles have much higher gravitational energy than the particles that these objects have. And in fact, their outer layer seems to have such low gravitational energy that there is no gravitational attraction whatsoever between that layer and the sun. They obviously have inside them some material that has higher gravitational energy, and they are able to draw matter from the sun through that interaction, which results from whatever energy they still have available. Now, stellar cores seem to operate like super ions, whereas normal celestial objects that are not old or dead stars, and therefore still have active gravitational energy generation ability in their cores, will have a positive inner core and an external outer layer of mainly electrons. So what brings stellar cores to the sun is the electrostatic interaction, as they are electrostatically attracted to the sun's outer layer of electrons. And this is illustrated here. We have a stellar core, which is basically a super ion, an object that has turned into an ion. It is depleted of electrons, whereas the sun still has an outer layer of mainly electrons, so it has an intact outer negative layer. Now, the fact that the incoming star can be tracked through its effect on the Earth, whereas many stellar cores have come in over the years and no such effects have been noticed, suggests that this object is not a stellar core, but a star that is still young enough to be able to continue generating gravitational energy in its core and still maintain a layer rich in electrons as its outer layer. So if that's the case, it will draw a current of ions from the Sun's outer nebular cloud once it enters the solar capacitor, which seems to go out past the orbit of Pluto. And you may read about that in Article 169 entitled Planetary Formation, Comets to Planets, and Article 170 entitled Comets, Planets, and Crustal Displacements. And here we have illustrated what the solar capacitor looks like. They're basically rings, somewhat like capacitor rings, where there are positive ions populating these rings. The Sun's outer layer is negatively charged, so any object coming in, mainly comets, but any object that has a negative outer layer will draw a current of positive ions and then a current of electrons from the Sun, and will then develop a comet's tail. That is, the interaction between the electrons and the ions will produce the emission of light and result in a coma and a tail behind the object. And so this is what happens with comets. So we would expect the same thing with a star that still has a negative outer layer. It should develop a tail inside the solar system. So once this incoming dark star starts drawing protons and other light ions up to sulfur, that's what's in the outer nebular cloud, there is likely to be a drag effect, and the black star would then slow down. And this is indeed what Terrell said the black star has done. However, if it starts drawing material from this nebular cloud, it should also develop a comet-like tail and should then become visible. And the fact that there has not been any forthcoming evidence about that may mean that either this is being hidden by the powers that be through the global sun simulation system, or that the light producing mechanism usually occurring in a comet's tail is being blocked by the star and its surrounding environment. Since the star has gone dark, we cannot be actually sure if the same mechanism that leads to light emission will actually work. I would think it's likely, but I cannot be sure. Now, details and evidence regarding the global sun simulation system are available in Article 160, entitled Sun Simulator, Speeds and Orbits, Article 165, Sun Simulator, Irrefutable Evidence, and Article 166, Sun Simulator and Lens System. And further evidence that a sun simulator, and it's not just one, but a whole system of them, is being used in the Earth's atmosphere, lies in the fact that more UVC radiation reaches the surface than arrives at the top of the atmosphere from the sun. And this shows that there has to be a source of ultraviolet radiation in the Earth's atmosphere. And this is detailed in Article 204, entitled Harmful UVC Radiation Reaching Earth's Surface Indicates Source Within Atmosphere. And the evidence can be seen from this graph, where we have the measurement done by Hendon et al. In 2017 and in January of 2018, and that's the measurements. You can see this is the UVC range, and we can clearly see that he measured UVC radiation, and the measurements were done at the Earth's surface, so there's UVC radiation obviously reaching the Earth's surface. But now what we see here is the measurement of UVC, of ultraviolet radiation reaching the top of the Earth's atmosphere before it can be filtered by the ozone layer. And as you can see, there is a certain portion of the spectrum where what arrives at the top of the atmosphere is less than what has been measured at the surface. And this means that there has to be a source of ultraviolet radiation between the surface and the top of the atmosphere. In other words, inside the atmosphere there has to be a source, and that source is, of course, the sun simulators that are operating within the Earth's atmosphere. Now, as to why the star does not emit any light, I do not think that it is because it has gravitationally collapsed. According to my theory, and therefore my understanding of star formation, the only real difference between stars and planets is size, as they both have dense solid cores. And in fact, I believe that the stellar cores, as they lose gravitational energy, their ability to remain as dense objects actually decreases, so they will grow in size with age rather than collapse into one dense object. So the larger objects, once they form, have larger and denser cores due to the matter composing them being made of heavier nuclei, and therefore having a greater percentage of unstable nuclei. The decay of heavy nuclei into lighter nuclei, or fission, seems to be the source of gravitational energy of all celestial objects, with the larger ones thus producing a larger amount of gravitational energy. This gravitational energy results in the separation of charge and the generation of a potential difference between the core and the outer layer, which gives rise to electric discharges and therefore light emission. The larger objects will have continuous discharging and nuclear fusion associated with it, and will thus emit light from their outer layers or atmosphere. In other words, the larger objects will be stars. However, my research has revealed that not only does the sun go dark periodically, it goes completely dark during the so-called SDO eclipse season. And that's described in article 202 entitled "What Will Become of Earth as the Sun Goes Dark." Well, that's only the latest article where I detail what occurred during the last SDO eclipse in 2017. I think there's been one in 2018 now, but I haven't actually looked at that data. Now, it also goes partially dark at other occasions, and this is detailed, one of these occasions detailed in article 205 entitled "NASA Indicates that the Planet X system is affecting the sun." And then I also detailed another such event in article 216, and that was on July 5th, 2017. So the sun goes partially dark when stellar cores interact with it. And this is during the SDO eclipse season. On the first day, we can clearly see that as darkness progresses across the face of the sun, and that the corona shrinks back as it progresses. And the corona not being there, if you compare what's here, if this was an eclipse, the Earth would be here, would be covering everything below the blue line, but there's no way the Earth can cover anything above that blue line, and therefore an eclipse cannot explain the fact that there's no corona there. If we compare these two, and the same thing on that side, you can clearly see there should be some corona up to that point above the blue line. It's definitely not there on the side. So this cannot be due to an eclipse. The sun actually goes dark during the SDO eclipse season, and the SDO eclipse season is actually a cover story to hide the fact that this occurs with the sun. And this is from the latest occurrence where the sun goes partially dark, and we can see that Cut-off lines are used to hide portions of the sun, obviously to hide the objects that are interacting with the sun and causing this to occur. And you can see here, if we follow this, the outline here of the interface between light and darkness, you can see it's a jagged outline, jagged edge here, and this would be like what we would expect to see around the edge of a coronal hole, but there's definitely no coronal hole there. So the sun has actually gone dark. This is at 20:45 on April 11th, and this is at 20:29. So that was just a few minutes before. You can see there's no coronal hole there, so there's no reason for this jagged outline. What is actually occurring is the sun has gone partially dark as these objects that are being partially being hidden by these cut off portions of that are added to the image or interacting with it. So the sun is also becoming progressively weaker as the stellar cores continue to arrive and to draw energy from the sun. That's detailed in Article 195 and Article 118, entitled Solar Activity Declining, Independent of the Solar Cycle, Is the Sun Dying? It does seem that even though the sun will continue to generate gravitational energy in its core for perhaps millions of years, it is eventually going to become completely dark because the stellar cores will continue drawing more gravitational energy from it than it is able to generate. And we know this is happening because the sun keeps on weakening and becoming darker. And at the moment, it even seems to be developing a coronal hole at around the equator position. So the time it will take for the sun to go completely dark depends on whether more stellar cores will continue to arrive, and thus the amount of energy that these objects will continue to draw from it. It is also likely that the sun will continue to have energy or enough energy to maintain an outer negative layer for quite some time after it goes completely dark. The time it will take for the sun not to have enough gravitational energy to even maintain a negative outer layer also depends on the amount of energy the stellar cores continue to draw from it. Once the sun loses its outer negative layer, it will turn into a stellar core, at which time its gravitational pull on the planets will be weak, and the solar system planets will then likely drift outwards away from it. However, this may take hundreds of years to occur. Or it may take less, but it's not likely to occur right after it goes completely dark. But if the sun is moving toward a time when it will soon not be emitting any light, and yet will still be able to exert a gravitational pull on its planets for quite some time afterwards, isn't it likely that this incoming star has already undergone this process, and that this is the most likely reason why it no longer emits light? In other words, the incoming star was most likely invaded by stellar cores, possibly before the sun, or perhaps at about the same time, but if it is a smaller star than the sun, and thus would not be able to generate as much gravitational energy as the sun, then it would have reached a stage when it is no longer able to emit light before the sun. And here are some more images. This is of another, sometimes I call these Planet X objects. These are the stellar cores that are found in the sun's corona. You can clearly see this one is striped. The stripes are curved. They follow the curvature of a spherical object, indicating that we have a spherical object in the sun's corona. And you can see plasma attached to it. The object is obviously drawing plasma from the sun's corona. So this is one of the stellar cores that have invaded the solar system and have come to the sun. They appear to also have been captured by other planets. Jupiter seems to have increased its number of satellites to a huge extent. It's possibly most of them are now stellar cores. the Earth seems to have captured some of these. These objects seem to be everywhere in the solar system, and this black star is most likely to have captured some, possibly even before they reach the sun. So this is the stronger, I believe, the logical reason why it's gone dark. So in conclusion, the dark star being tracked by Terracraft does not appear to be a stellar core, but is most likely one that has been drained by the system of stellar cores, which are now draining the sun and weakening it, and will eventually cause it to go permanently dark as well. And here are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.